We are
Hi,
back.
folks. Hi, folks. I am very happy to be back streaming again and chatting with you in the new format. Look, this is something new we're trying. I'm very, people, the reaction for people has been really nice. And so maybe we are keep doing it. So very happy.
Yeah, I think it's. I mean, the main reason is that you and I chat a lot, and most of the time we chat about things that could be extremely valuable for a broader audience to be, uh, you know, uh, heard and discussed. And so we said, well, let's jump on a call every week and chat with
Yes,
everyone. Um,
absolutely.
I think while we warm up a little bit the room with the people that are latecomers or they're just joining, um, we can maybe quickly uh, go through the usual, like a quick intro, and we can then jump into reconnecting where we'll, you know, stop last time and where we are going today. So maybe Theo, for the people that they don't know you, which is very hard. Um,
Oh, you don't know?
a
There are
quick,
people that don't know. Come on, it's not possible. No,
maybe
I'm
a quick
joking.
intro about yourself. That would be great.
Fantastic. So, Uh, I'm Matteo Collina, Platformatic co-founder and CTO, vice chair of the Node.js Technical Steering Committee, board member of the OpenJS Foundation, creator of many modules on npm. There is a very good chance that you're using my software, either that you like it or not. Okay, it's somewhere in somewhere with something like 30 billion downloads in every year. Maintain, as I said, use my software and so on. Started with a good, nice startup with Luca, Platformatic, which is sponsoring this podcast. And yeah, that's it. What about you, Luca?
Um, I spend my life building companies and selling them, but also kind of like helping enterprise to design this large scale platform and systems. And I came across Node while I was selling my last startup, so back in the days. And since then, I kind of like loved the opportunities behind that. And so today, I'm the co-founder and CEO of Platformatic, and what we are trying to do, because we basically didn't tell anybody. I mean, yesterday we announced a new feature that is changing the game, and I think it's completely connected with what we are talking today. But what we are doing with Platformatic, we are rethinking some of the tools that are needed for Node to be extremely successful and easy to use in large scale, in enterprise, in many environments. And last week when we were chatting, I think what was extremely interesting for me, at least, was that we touched upon many points. And one of them that we said, oh, we should talk about it next week because it's way too big, is basically where the question that we ask ourselves when we built the new, I say the new product, like our commercial product, but the question was um, basically, how can we make a node excel in Kubernetes? Because let's be very honest, every company uses Kubernetes. Well, a few of them, Theo, they
Oh,
they go into
all of them.
serverless, right?
All
But
of them. Well, in my experience, most relatively big enterprise are deploying on Kubernetes. There is always some serverless being used everywhere, like typically some AWS Lambdas being used everywhere as sort of some form of glue code. But the heavy lifting of the deployment is done in Kubernetes, mostly because of cost reason, and second is also performance reasons, to be honest.
well, but also because organizations, one way or another, they found in Kubernetes a great platform, between quotes, to build their platform, right? That was the promise, right, of Kubernetes. But what I think it's actually super interesting is and I one thing. We say that at the end we should talk, but we started immediately hot today saying serverless.
Yeah,
And I'm
super
gonna
hot.
say let's park it for next Wednesday. Serverless. Let's talk about
Okay,
serverless
let's talk about
next
serverless next Wednesday. Okay.
Wednesday, because I know that you and I are gonna, or else we're gonna go
We are
there.
going to talk
So,
about serverless and not, Kubernetes. So
but
let's
but
talk
but
about
let
Kubernetes.
let's talk about boring enterprise stuff, Kubernetes. Next week we talk about like microkernels, micro VMs, serverless, and what I call the biggest scam of the first cloud initiative. It was not even a revolution, but um, I think what is kind of interesting about Kubernetes, and you and I kind of like mentor also people, and a couple of weeks ago we were just like talking about that with one of our customers, is that Kubernetes started and it still is an orchestrator of physical resources. You deploy a cluster with nodes, you assign CPUs and memories, and you shuffle anything in. It's the generic layer. I don't even call it a platform, layer on top of physical infrastructure. I mean, let me say something provocative. It's nothing new, because with VMware, ESXi or VMware, you could do exactly the same, but there's a pretty nice user experience API. People are going to hate me for that, but I think it's the truth, right? Kubernetes brought accessibility to people, to the infrastructure.
Yep.
But then we have the world of Node, right? That is purely logical. So I don't know. Let's maybe you're the expert of Node,
Okay.
so I'm
So let me try to go that a little bit. Okay. So Node.js is to some extent, yeah, Node.js is great. Okay. Can run a lot of concurrent requests inside the same process, okay, without having to create a lot of resources, without having to allocate a lot of threads. So you can, instead of running 1,000 of concurrent requests, you can run 10 of 1,000, you can run 100,000 concurrent requests on a node process if you want to do that. Okay, this is great. And essentially, it has been elected as probably the best tool for the everyday programmer, I would have to say. Okay, it's there are specialist tools for everything, but it's it's a generical tool. Okay, it's more or less good enough for most tasks these days. So it works well, good enough for more or less everything. Not the best choice for probably anything at that point, because if you are a jack of all trades, master of nothing to some extent. So Node.js is it's great, okay. However, it's built on a few key tenets. Okay, first of all, is an event loop based system. Okay, which means that within a thread it executes more than a request. Okay, but this means that only one of them is active at any given time. Okay, it's scheduling async work and it needs to react to that async work, and when it's done, and so on and so forth. Okay, so this means that every request has a tiny little bit of amount of CPU time, okay, to do its work.
And Matteo, for our audience, let's pin it for next week. Let's remember what you just said next week, because it's going to be useful, right?
Yes, of course. Yes, let's pin it for next week.
Let's
You
pin it.
guys
Let's
remember
pin
what I
it.
said. Okay, Node.js is designed and built to run more than one request on a single socket. Okay, on a single server. Okay, this is the key part of Node.js. Node.js is built to do that. Okay, that's the reason why Node.js was built. Okay, run
And
more than one
Matteo, just
request.
because I know sorry, I didn't mean to cut you, but many people, they might say, "Oh, okay, but I heard it different." We forgot to say in the beginning that anything that we say is recorded. You can use it. You can use it as a proof. And we also have summaries at the end of our episode. So everything is at hand for our listener to be used in their organization, in their conversation. That's what we are trying also to trigger with people, is an open conversation about things that might be unknown for many, or, let's say, misinformed. So that's also kind of like the value of what we are doing. Sorry, I didn't mean, but I wanted to say,
It's
because
fine.
maybe
It's
somebody
fine.
was taking notes, and I said, "Oh, no, don't waste time taking notes. It's going to be recorded."
Okay, so we have Node.js work in this way. A lot of tiny list size of time. Okay, what this means though is that if you know a little bit of how Unix socket works about TCP, okay, it means that a socket is accepted, okay? You accept an incoming connection on a server, okay? Then you receive all its payload, you receive all the data for that socket, okay? Then it's processed, then that request becomes an HTTP request, then that HTTP request needs to hit a database, and it's your handler needs to hit a database, does some more IO, you get a response, you send a response back, okay? All of this time happens across many what's called event loop ticks, as much as a lot of different steps have been done, okay? This means that your node process can accept a lot of incoming HTTP requests, okay, but not have enough slots to do all this flow, okay? It can accept a request, okay, but in fact it has accepted it, but I have so many things that I need to do now in my event loop, in my everything, that I can do anything with it in less than 3 seconds from now. And we all know that a user, if he doesn't see a response after 1 second, it hit refresh. So basically, anything we spend doing this work is absolutely useless. This is bad, okay? So how do you prevent this? Okay, well, you could say that you can start scaling on CPU based on your, you can configure auto-scaling capability on CPUs and so on and so forth. That, however, it's typically is at post measure, okay? You can see it that the CPU measurement typically lags a little bit. What can you use? You can use something called event loop utilization, phenomenal thing. You will get a link in the summary, okay? Originally created by our friends at NordSource. Hello, hi guys, okay? And that they contributed this to Node Core, okay? So great companies develop features and they contribute them back to Node Core for everybody to use. This is great, okay? So there is event loop utilization built into Node Core, gives us a key indication of how much CPU, how much of your event loop, okay, is currently being used. If it's 1, okay, there is no more availability left, okay? If there is 1, probably there's no point in accepting that request. If the event loop utilization is 1, it means that your event loop is actually staying behind, okay, and accumulating events to process. This is bad, okay? So, however, if you do Kubernetes, you scale typically based on CPU. But we said that the CPU really doesn't matter. Well, it doesn't, because in a lot of cases, especially if there is a lot of, if you're receiving a burst of traffic, okay, if you receive a burst of traffic, it can, node can decide, okay, at any point in time to run a lot of other things, okay? For example, it can run the garbage collector on a separate thread, or it can run, or you can run something on another thread, because Node.js is multi-threaded. Okay, so you can spin up a thread for doing some asynchronous processing. But the main thread is the one responding, so that's where you want your measurement to be clear. But also there's all the other thing running in the process that can inflate your CPU utilization. And yeah, you don't really want to scale on that, because it's not inward enough. Okay, it does not tell the whole story. Okay, now there's the second point is about memory, and frankly, this is probably the worst thing. I've seen a lot of people doing when doing Node.js systems. Okay, super bad memory. Well, so they say, okay, they configure Node so that it has a limit of a pod in Kubernetes. It has a limit of 2 GB of memory, right? Fancy. Now, then they decide, okay, that at 1.5 GB, okay, they will kill it, because they will send a soft kill signal because of, oh, but you're reaching the maximum, so I'm soft killing you and restarting. Now, let me tell you a very bad secret about Node, okay? Node.js is, and V8, okay, is lazy, as lazy as possible. It allocates memory, okay, and it will clean it up, okay, when it either immediately because it's something that's just used now, okay, but if it takes a long time, if it's an object that's alive for a bit, it survives for a little bit of time, then it will keep it around until it has time to clean it up. Now, I don't know how many of you are familiar with defragging, okay, defragmentation, okay. Now,
Well, everyone that is as old as we are and use at least once Windows
yeah,
from
yeah,
3.1 to
this
XP.
is what I'm saying. Okay, like if you ever use the FAT32 um, system, okay, you know what I'm talking about. Well, if you haven't though, okay, gosh, I'm sorry.
Google it.
Google it. Okay, you will see something nice. Okay, so what it happens is that Node.js keeps allocating all those memory. Okay, and then okay, every once in a while it pass and mark and then mark all the objects that the things that then cleaned up, and then it starts going and cleaning it up. Okay, but it acts slowly over time. Okay, and because of that, okay, it takes quite a little bit of time, okay? And so, especially during a burst of traffic, Node.js is actually prefers to keep the memory running for a little bit of time, okay? And it typically allocates memory in chunks. So it takes, okay, oh, I'm using a lot of memory, so I'm getting another, I don't know, 64 megabytes of RAM now. And use the concept of a heap to put those objects in. Is it ever going to release that memory? Well, yes. In theory, yes. When it's not using it at all anymore. The practice, though, it's something very rare. Okay, so essentially, do not kill your Node.js process at 80% RAM utilization or something because that's not good for it. Okay, it's normal.
Well, Kubernetes is not going to kill it. It's going to, inside of the replica set, the autoscaler will basically detect that pods are reaching a limit. And so it's going to spawn new instances over and over again. And I think that's the major issue in Kubernetes, right? Because those resources are used. So they're consumed. They're not really kind of like, available anymore. So it's physical resources that, like you were saying in the beginning, pods have a pre-allocated size and a pre-allocated memory set. So they're going to be removed from the cluster availability. So that's kind of like the game, that if you don't scale, if you don't detect correctly when node is really at the edge of needing to be scaled, then you are removing resources that are valuable maybe to other applications just for the sake of like filling an autoscaler.
Yay.
Which kind of like comes into cost, comes into clearly many kind of like side effects on the cost of your cluster. I think there was a question while we were talking, Theo, about explaining more about buffer. An example on.
So when you locate a buffer, buffers are the binary data in Node. When you locate a buffer, okay, what you get is a JavaScript object that refers to some memory which stays in the array buffer space. So it's not allocated within the normal heap. So that's fine, okay. How it helps? It's just how things are. It doesn't help in the sense of if you use it, it's helpful. You use it if you need to deal with binary data. It's otherwise don't use it. This is my take. If you don't, converting stuff to a buffer has a cost. Serializing it, okay. So you do it if you need to. That's my point.
Good point. And but you know what is kind of interesting, like we touched a little bit about the autoscaler, and I think that's kind of like the elephant in the room when talking about Kubernetes and Node. And the reason probably why Kubernetes doesn't have specific for each runtime is that every runtime is different, right? Like if you were to run a Go, a Java, .NET with .NET Core, or I don't know, Ruby, anything, right? They have different kind of like ways of like and thresholds. But where I think it's kind of like interesting is that many times you and I heard. You remember when we worked together and there was this movement about microservices, which I mean probably we should address in this chat. But you know, we came to Kubernetes, and let's jump into it. We came to Kubernetes because Kubernetes came along with the microservices revolution, right? And the so-called agile movement. So we kind of like saw this kind of like match made in heaven between Kubernetes Node, an apparent match made in heaven between Kubernetes Node and microservices. And so we kind of like, when I say we, I mean the community of technologists and especially architects, especially, you know, leaders, saw this opportunity of building this kind of like micro nano components that would basically use the least amount of resources because we could scale them horizontally in a massive way. Because you remember at the time that they told us everything needs to be stateless, and then everything converges into a database. So I mean, you know, it's a contradiction in terms at the end. But I think it's interesting to kind of like go a little bit deeper into the kind of like resource allocation microservices. And you and I many times have been kind of asked these questions. Why is it bad to associate you know, micro CPUs or you know, tiny small fractions to node, and why not scaling it massively horizontally? And I think you touched, right, because there's a lot of misconception, but I'm interested to kind of like hear your point because you and I
Okay,
chatted so
so
many times about it.
first of all, the first thing, okay, is the misconception of how much CPU power you need to assign Node.js. So, or in other terms, okay, is one CPU, virtual CPU, whatever, enough to run Node.js well? Well, the answer is likely no. Okay, you are going to constrain it. Okay, so it's going to run in a non-optimal way. More or less, you need to give it a little bit more at a minimum. Okay, because there is still a lot of other threads running, like the garbage collector, the code optimizer, lot of tasks from V8, lot of tasks for Node itself. You know, if you do file system operations, some of those will run on the thread pool. So you need multiple threads, okay? And so therefore, if you want to run at maximum speed, you probably need something between one CPU and a half, between one and two CPU, something between one and two CPU per pod, okay, to run it at peak performance, okay? And the second part is now, as we told, okay, you can now run Node.js. Node.js is multi-threaded. You can schedule thread in Node.js, as we said. Okay, so you can detach separate thread to do other things, especially things that will block the event loop. Okay, and therefore slow down the response to your customers. Okay, so what do you do? Well, if you have if you have a task that will take a long time, okay, and will be CPU, will have a lot of CPU, requires a lot of CPU power, you could essentially create a worker thread and send the request to forward that request to that worker thread to process, okay, and then send it back. You can also limit the amount of requests that are going to that specific worker thread, okay, and say, for example, okay, if there are more than two in queue for this processing, yep, no, reset it. Don't send it. Send an error. This is busy. Send a 503. Maybe the load balancer will forward this to some other pod for processing. So, yeah, that is fundamental, though. Okay, if you don't know that some operations can take a long time and that are CPU intensive, and you ostensibly run them in the same thread, you're going to run into trouble. Okay, huge trouble.
But I think it's interesting that, you know, in all our conversation, it was always kind of like back to the misconception, right, of microservices and Node and Kubernetes. I think, and once again, I'm shouting the provocative statement here. I think Node started with that idea, but naturally and organically it evolved into aligning more with other technologies that that they run that they exhaust resources in a kind of like more vertical way than horizontal way.
It's both. You can't do just one. Okay, in order to be performant and use all the resources on a machine, okay, or use the resources in the best possible ways, okay, you need to combine threads with event loop technology. Either one, having only one of the two, it's not enough. Okay, you need to essentially do both, because there is only so many, like an event loop runs on a single thread, right? So there's only so many things that you can run on a thread. Okay, and therefore that thread will be busy. So then you need essentially another event loop for another thread, another event loop for another thread, and so on. So you can scale this in a very nice way. Okay. This is the pattern that is today. I think it's the pattern behind Nginx. You probably know better than me now in that side, but I think Nginx started with pure event loop, then added threads. Okay, is the pattern behind, for example, Valkey today. Redis originally had only event loop, was only event loop based, and then recently it moved to event loop plus threads. Okay, because you need to do both to achieve the highest level of performance. Because guess what, our hardware has multiple CPUs available, so you should do something with those. Okay, and running full containers, full pods to take, and full processes to leverage all the cores is more expensive than just spinning up a new thread. So spinning up a new thread is actually nice. So you might want to do that. That's it. Okay.
Yeah, but the thing is, Kubernetes doesn't prescribe that, because it's just a scheduler, like that you use a CPU, that you use kind of like that you assign cores to a virtual CPU for a certain set of pods, or you want to use a physical one or whatever. Kubernetes doesn't care. It's a purely physical resource scheduler. And it says, well, I know there is a certain workload that can be distributed across the cluster, and I know how to manage it, and I assign it and deploy it. So I think it's purely self-inflicted pain sometimes what we do as engineers, right? To kind of like try to twist, I would say, the nature of certain tools. And I think next week, if we go deep into, I think, serverless, it will be extremely clear why, provocatively I've said it was a lie. It is a lie. But I think going a little bit more into the microservices, right? Just to kind of like give more context probably to whoever is listening right now. What do you think? I mean, if we could take a time machine and go back in time, would you still prescribe to the original definition of microservices? Knowing now, with all the knowledge that we have right now about Kubernetes and
so the fundamental problem, okay, of and the way a lot of smart people try to define microservices versus services versus whatever, okay, it's the key part of the microservice definition that most teams, or I would have to say close to all teams, seems to forget, is that microservices are a unit of deployment. Now, this is the key fundamental tenet of any microservice book. Will start microservice are a unit of deployment. Okay.
Well, they also define it as unit of logic and so on.
Unit
but yeah,
of logic,
fundamentally,
and so on and so forth. Okay. And then in practice, the vast majority of the projects doing microservices that I've seen, what do? They deploy all microservices at the same time, which are developed by the same team. They are QA'd by the same team, okay? And everything is just shipped as a massive distributed monolith.
But you know why, right?
Oh, I know. Do you know?
For sure. That I mean, I would love to actually to ask the audience if we had if it was one of our conference, we would probably stop and say, please raise your hand if you know it, and I would ask
Yeah.
to somebody, what do you think is the real reason? But I
Yeah.
think we already said it earlier, right? I mean, is everything is connected to. I mean, once again, today I'm going with every 2 sentences something provocative. With the other kind of like lie, if you want, the DevOps kind of like mirage, right? To say, well, I need to kind of like being able to deploy independently because I need to scale independently because a service might have more traffic than another, right? And so we build a replica set, we put down there a microservice, and this microservice basically uses an insane amount of resources for the reason we said before. But there are a million of other ways to do it, right?
Yeah.
So I think
But
it's a self-inflicted pain and gain.
it's even more problematic, okay? Because the point, usually, if you look at the team building an application, okay, the team building an application usually is composed by a few people, okay? It's a
Yeah.
team, okay? It's Amazon. It's a two-pizza team, okay? To be honest, I'm putting it in a it's and when you have a two-pizza team building something, okay, doing microservices is probably not the best choice, okay? Because essentially all people are working together, crammed in a room, crammed in a Slack channel, whatever, working remotely, but still pushing out on the same repo, on the same group of projects, okay? So, yes, they can deploy a couple of things separately because they need to scale independently, and there are components that needs to be scaled independently, of course, okay? They exist, okay? You need to recognize the problem and address it in that way, okay? But most of the time, this is not needed. It's absolutely self-inflicted pain. I was literally on a team at some point saying, okay, you built your system. We have, I don't know, 12 microservices, okay? Each microservices is deployed, it's a replica set of 3 pods. Okay, each one with 2 gigabytes of RAM allocated. Why? Well, because if it reach 1. When it reach 1, because we kill it when we reach 1.5, so we had to raise it until so that the 1.5 limit doesn't kill it. Okay, so that the 75% limit does not kill it. Okay, whatever. This is the problem that I described before, which means, but then we replicate this in another location. Okay, so they had 12 microservices. Okay, 2 gigabyte RAM each. Okay, 2 gigabyte RAM each, times 3 times 2. Luca, you're very good at math. How much is it? How many memories? How much memory is that?
I didn't hear your math, sorry.
Okay. So we have 2 gigabytes, okay, times 3, so it's 6 gigabytes.
Easy, this one we can do it by head.
Okay, then we have 12 of those, okay, which is 72 gigabyte of memory, okay?
Yeah.
And then we double it. Because we know everybody needs to have 2 availability zones or 2 Kubernetes deployment, whatever you want to say, but you need to have one hot, ready to take over in case the first data center burns. And by the way, data center burns, so you need to have a backup on another availability zone if you're doing reliable software. Okay, so wait a second. So you're saying that in order to, but add this up any traffic. Well, no, it doesn't. Okay, it does not have all the traffic that needed all those machines, all those things running. In fact, most of them were running idle. What? So that's the problem. Okay. And
yeah, I mean it's kind of a. I was sorry, I was reading. There is a mention in the chat that probably you can also see without me having to read.
Yeah, I can read it. So there was a comment. So I thought about assigning 1.5 CPU to a single Node.js pod. We have observed that handle quite several requests, and we scale by the number of requests. We have observed just a few CPU millis, even 200 millis. We're able to handle the load perfectly well. We will go with just one pod in some cases. We have a minimum of two in a case. We have a crash, for example. My point is, it's very unlikely you need a whole CPU to handle your traffic. And if you want a certain degree of availability, you'll have at least two pods. That will mean three CPUs in that case. Uh, well, I'm not talking like, okay, let me clarify. When I say you need 1.5 CPUs, I'm talking, let's say that you have 100 pods doing your tasks, okay? And you want to get the best out of each one of them. Yeah, you probably want to crank it up, okay? Of course, if you don't have a lot of traffic, you can do it uh, uh, um, with very low resources because you don't have a lot of traffic. I'm talking about a lot of traffic. Okay, it's really peak time. Okay, so
You know what I love about this, Theo? That
yeah,
I mean, we're not here to sell our product. However, for everyone listening, you should really check our command center. It's gonna solve all these problems in Kubernetes. But you and I, and we mentioned it last time, back in March of last year, we were sitting in Amsterdam chatting about like some vision, and one thing that we discussed was the autoscaler, right? So it's not a secret. Uh, we built an incredible autoscaler that works perfectly with Node. That's it. Is uncomparable to anything that is on the market, and personally, I think is a de facto standard when running Node in Kubernetes. Apart from that, what we actually look is that there is a lot of times that people do the so-called a priori allocation of resources. So they put a finger in the mouth, feel the wind, and say, I can use half a CPU, it's fine, right? But that's a completely wrong assumption because you don't know, right? So what we kind of like thought, and that's what we built and released actually yesterday, is the concept of organic homogeneous resources, right? So we believe that the world where we have all a priori choices in Kubernetes is over, right? So the thing that we need to implement is so-called live organic, allocation. And so when it's nice, I'm personally kind of like excited when I see people like pre-allocating resources because I said, well, anyhow is wrong. You will never do it right because Kubernetes is also something called the vertical pod autoscaler that allows to do vertical pod allocation. So you can change the size of your pod depending on clearly not live. It has to be instrumented into the autoscaler. So the autoscaler is going to instantiate a new pod with the new resources. But that's actually what I think is super cool is that, and is very unknown by probably the majority of people, like Kubernetes was designed to implement multidimensional scaling, so vertical and horizontal. But what is actually more interesting is what we kind of like did through Watt, which is open source. So we're not really selling open source, it's just you can go online and download it. By the way, I don't know if you saw, but in 18 days, we actually crossed 862,000 downloads. So this month we're going to cross 1 million downloads in Watt, only in February. Close bracket, and a little bit of closing show off on our open source. But what is interesting is that we can allocate definitely all those threads dynamically. So you can actually have a pod that is slightly over provisioned, and then it's going to be massively overutilized, or let's say compacted utilized, thanks to basically how Watt can replicate threads within its own instance. So I think when looking at these use cases, my suggestion is always, I would definitely never have one pod, and because one pod, when the pod exhausts to restart the new pod, you have downtime. But definitely, I would probably look into a more kind of like data-driven way of scaling those pods than doing it a priori. That's at least my point of view. I don't know yours, but I think we are very aligned on resource utilization. I'm checking the time because you and I could talk for probably the entire day, but I think we are reaching almost the time that we promised, the 45 minutes mark. And I think actually what is nice to share, we always share stories, Theo. Why don't we find a nice story that we can tell everyone of a nice use case or something that we saw in our life
Look.
about
I
Kubernetes?
am going to touch about a different topic, Kubernetes.
Go on.
Okay. So, and why it's very hard. So Kubernetes, some time ago, and this story is a meld of probably 5, but I am, summarizing them in one because it's the same problem. Okay. So long time ago, I started doing consulting gigs, companies deploying Node on Kubernetes. And they were doing HTTP requests between 2 services. And, if you know the default HTTP request system, okay, in Node, HTTP.request and Axios got all those things. And by default, it was creating a new socket every single time. Now, something that most people don't know, especially also if you're using Alpine for your as your base image, okay, is that there is no DNS caching at all in Node. And if there is no DNS caching in the operating system, is when Node.js asks for creating a new socket to a certain domain, is going to do a DNS request for that domain. How that happens, what happens is it's going to do that, it does that request and comes back. Now, after it has done that request and comes back, it issues an HTTP request. However, all DNS requests in Node.js, internal specifically, if you go talk internal to the pod, end up into the Kubernetes controller and the etcd and so on and so forth, which, which were being literally hammered by microservice system, creating HTTP requests between the services, bringing the whole Kubernetes cluster down, close to, okay? And literally, this was creating so much downtime, okay, everywhere, to the point that in, I think, Node 16 or Node 18, I don't remember, I would need to check, okay? I actually flipped the setting in Node Core so the default HTTP agent was a keep alive connection, so we didn't need to go through all this DNS cycle all the time, so that the HTTP request will stay up, okay?
Well, sorry, also just to, sorry not to interrupt, but because Kubernetes, what it does in the pod, the pods inside of a replica set or a service are isolated. So when they call for the domain of another service, they actually do a lookup to the main DNS that only the main controller has to go down to the other pod, right? And it's not cached, so that's.
So one of the solution here is to implement DNS cache in the Kubernetes host, okay, in the various nodes, and therefore so that your Node.js pod calls the DNS cache thingy, and then that DNS thingy cache go to the top only when that DNS entry expires. It can even be every 10 seconds, but it's actually, when you're doing microservice calls, you're talking about thousands and thousands of requests per second. So these can be pretty daunting in terms of things. Now, it is even worse. This something that happened not so long ago. Okay, I had a bug in my code, and I ended up doing a lot of HTTP calls in a loop. Whatever, very bad bug. But what happened was that it was because of this, okay, it was creating so many UDP socket, because DNS runs on UDP. So many UDP socket that was finishing up the UDP socket pool. And this was so damn bad, okay? and it was literally causing problems all across the system and so on and so forth. So you need really to keep an eye on those kind of problems, and that are not easy to debug at all. Okay, you need somebody with experience to, like, I could spot this kind of problem in a pinch. Okay, but a lot of people don't have this kind of experience, or are close to the problem, or now things work internally. Okay, so yeah, that's the story that I tell. Okay, and this happened so many times. The last week, what happened last week? So it keeps happening and happening and happening. Okay, and yeah, at some point I would probably do something about it and put in a DNS cache in Node Core. Probably we should, but that is actually not that simple. So yeah.
Yeah, and I mean, once again, it's always the dog biting his own tail. Kubernetes is going to prioritize his own system resources for doing DNS resolving, and then he's going to remove it from the resources in the pool. So I think it's kind of like interesting to explore those problems. We are at time right now, and I'm half Swiss, so I'm trying to be on time. But I can see that there are some questions.
Really nice questions,
Let's
actually.
chat. Um, let's maybe pick a few. Maybe there are 6, so let's pick a couple now, and the other one we are promising to answer to them in our summary. Does it work for you, Theo?
Yeah, let's do
In
that.
our summary, we write the question and the answer. I
So
think it's going to be
I'm going to
easy.
take I'm going to start going at the first one very quickly. Okay.
Yeah.
Can you please talk about configuring max old space and max semi space in tandem with CPU memory allocation to tune performance and provision replica set correctly? Now, this I can explain this. It's probably going to take 2 hours. So what I'm doing instead is I am preparing some material. I'm preparing a talk that will then be available everywhere on YouTube, blah, 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 where I'm going to explain this in details. Okay. And how to tune it with Node.js specifically. Okay. So that you can tune maxwell space, semi space, what those are, how the garbage collector work, and so on and so forth. So you can follow my reasoning behind that system. It's going to be a fantastic. Then to become a blog post, it will be, it will come, it will get everywhere. Okay, I have a target date, so wait for it in April or something like that. So
Yeah, I see there is a question about platformatic, so let me just take that one. And it's about what can be used for as a regular developer to try to build the app with Next.js for a startup idea. And this person heard about what. I think you nailed it. I mean, the what is open source, can be used. The feature that we released yesterday, so FCC, Fusion, Fish, and Cascade, they are actually only for our commercial, so not available for clearly the open source. But definitely what is a great starting point. We are releasing soon some interesting implementation on how to use what, for example, with open source e-commerce frameworks, or with Remix, with many things. Next has already been published back in December. So definitely we have some documentation online. We're going to probably link it in the summary. So for this person, you will find the links for easy access. But I would probably start using, I mean, I'm not trying to sell what we build, even if I am. What is, I believe, the new foundation for building Node at scale? Like I'm saying it here, Node is a great primitive, but Node needed something to handle an overlay on top of this runtime to make it a real foundation.
what
And
to add one more thing, Luca, what
go.
does for Next.js, okay? If you use Next.js with VAT, and there are a few tutorials, okay, you get a few good things. So VAT runs your Node and Next application as worker threads, separate worker threads from the main thread. The main thread is left as a watchdog, essentially, for all the things. Okay, it provides all the metrics endpoints, so you get all the configuration automatically for your metrics to be fed into your Prometheus and Grafana and so on and so forth. Okay. you get a liveness check and so on and so forth. But for Next, you can also get, just by flipping a config, the ISR cache automatically built in. Okay, and you can point it to Redis, whatever Valkey, whatever you use. So that works out of the box. Okay, and you just feed in, and it will be implemented. Okay, so essentially provide a very good way to essentially self-host your Next.js applications, and so that will be, I think, quite good.
Yeah, sorry, I was taking a note while you were talking of an idea that came to mind. I will talk to you
Good.
about it later. Yeah, I think we are at time, and for all the other questions, we are gonna answer them in the summary. So you will find there the answer to your question.
Oh, look, we have a yay! That's great.
Oh no, I made a mistake. I looked at the wrong time. We still have 10 minutes.
Yes, so let's keep going.
I don't know why one clock it tells me that it's almost 9.
Look at it's
I don't
10
know where it
minutes.
synchronizes this clock. That's
10
a
minutes. Come on. Okay,
well, we
so
have 10 minutes.
okay, so there is a few more thing. Practical configuration for scaling based on the event loop utilization. Well, I like, frankly, if you configure correctly, it's fantastic. Okay, super good. Okay, but very, very hard to set it up correctly with probably a little bit too many moving pieces for most teams. At least this is what I've seen in practice. It was very, very hard to set it up for most teams because it typically requires cross-thinking between a lot of different teams in a company.
Yeah.
So you need your ops people to coordinate with the developers, to coordinate with DevOps, to make everybody happy and content with this kind of system. It works super well. Frankly, it's phenomenally good. Okay, specifically because the Kubernetes autoscaler is kind of smart and look at the projections and things. Okay, and if you configure this right, it can see a spike happening very quickly if the event loop is going to be busy, but it's a little bit more stable if compared to the CPU based system, the CPU based autoscaling. So it's it is doable. It's just a little bit of a lot of config, to be honest, to set it up in Helm and everywhere.
Let's be very honest. It took us a few months to actually build it right. So
Yeah.
and I think that we have enough depth to know how to solve some of the intricate problems, and it took a while. But just because there are synchronization problems, there are like you were saying, projections. There are many things. There are moving pieces that needs to be taken care of, and plus, like I said, Kubernetes is a great generic tool. It's not a specific tool. There is another question. You mentioned CPU as a lag measure for autoscaling. I would love to know the practical configuration for autoscaling. Oh, it's the one that there are two of the
the
same
one
question.
I answered. Yeah.
There is a follow-up question on the buffer. What is a practical example when you can actually say, here I really need a buffer so my application can run well?
There is either you need a buffer or you don't. Like there is no my application can run well. Do you need to create and send binary data? Then you need a buffer. Okay. Typically, if you need to convert, typically you need to take something. For example, let's say you want to send down a protobuf bunch of data. You need to take your object, convert it to protobuf, and sending it down. Okay, that's great. That's when you need a buffer. Okay,
I could guess it. I could guess I need a buffer. I don't know. I was just saying, hey, I need a buffer because it's a protobuf.
Okay, yes. But
I
this
was
is true
trolling
also
you.
for message pack, and message pack does not tell it's not in the name, so it's not in the name. So you don't know. You can even there are all these kind of protocols that are binary, so data formats that are binary in nature, that they can be used for buffering. Okay, so they you need to work with buffers to create them and then send them down. If it's not binary, you are better off not using a buffer. Okay, it's very simple as that. Okay, so because buffers are genetically expensive. Okay, and so you're better off using JavaScript object, higher level concept, and so on and so forth. They're not expensive, but they are. Imagine like that. If you have data in a certain representation and you need an object to process it, every time you put into a buffer, you copy it, and you do copy from one region of memory to another region of memory. This takes a lot of time. Okay, takes a lot of time. Okay, and which is bad. Okay. Now, if you're using memory, so you don't use buffers when they're not needed. Okay, you're using buffer only when they're needed, and that's it.
I don't know if you remember, but once we interviewed somebody, and and there was a similar question, and I remember this guy actually asking us, yeah, but what if I needed to? No, we asked him, and what if I need to transfer an image? Because imagine that you are a web server. What if you need to transfer an image? And there was like this infinite story that it was kind of like funny because this person didn't know that an image is also a memory buffer. But that I just came back to memory. There is a question on again platformatic. I feel I'm taking them all. If I'm using something like managed Kubernetes, like GCP Cloud Run, can I still use platformatic solution for my Node.js app optimization? So Cloud Run is actually not really Kubernetes. But if you are using
It's
any
based on
managed,
Kubernetes. It's based on Kubernetes. Come on.
is based, but is not Kubernetes. It's like Fargate.
It's so what you can use with when you're using Cloud Run, you're probably using Cloud Run because you have some sort of automatic GitHub integration. Then when you push the code, it automatically gets deployed there, and you're using in some form of with Git push type of solution, where you have a very lightweight DevOps system. Okay, so Cloud Run has two key things. Okay, in Cloud Run, you can configure how many requests you can funnel to your node process. Now, I think that's still pretty limited. So I don't think you can reach maximum level, peak level of throughput from that system, but you can feed more than one. Okay, and we can talk a little bit about serverless and Cloud Run too next week. Okay. But what you can use with Cloud Run, because they're still long-lived processes, you can easily use VATPM so that you can get this sort of Prometheus and so on and so forth built in to do all of that. So I think you can use that.
Yeah, but Cloud Run is not Kubernetes because it doesn't have the primitives of Kubernetes. Like it doesn't have the ingress controller. So it has a different model that is more into long-living serverless than pure serverless. But because we know a person very deep into Cloud Run, actually is one of the things that we're going to experiment along the year is to see how we can actually have our command center to operate with systems similar to Cloud Run because they have a similar API than some of the KTest primitive. But yeah, like Matteo was saying, Watt is probably you can run potentially Watt anywhere but not Lambda because it would not make any sense.
Yeah, we'll talk about it Lambda tomorrow. So next week.
And to be honest, I don't think you can. You must use Watt PM with Node anywhere but in Lambda. So if you're not using it right now, you should go npm install Watt PM and start using it. That's nowadays, to be honest, we run even internally for our dev, we run everything in Watt. I don't think anybody of us really runs Node straight to the point. We just run Watt. There is a last question and 1 minute left about keep alive default settings was changed in Node 19. I remember this well because after upgrading to this version, we suddenly started receiving a massive amount of socket hang-up errors. We are using many third-party SDKs, so we are not in full control of how HTTP agent is used. Finally, we decided to restore keep alive false in the global scope, but it's a performance trade-off. Do you have any recommendation on how to prevent socket hang up with keep alive true?
Use 11. That's the solution. There's no fixing. Like this, so to fix this problem, essentially, we created this new HTTP client called 11, which is massively more performance, and you can use it all the time, okay? And it works so well. So just use it, okay? That's what it is, okay? I don't have any other solution compared to use 11. 11 will more or less take care of this in a very good way, okay? We did a few fixing since that thing came out. So we actually improved the scheduling algorithm, fixed a few bugs, so that all those socket and gap errors should happen way less, okay? But 11 is essentially latest version of 11 solves all of them mostly. So you should not see them if not sporadically. And it's also way better to at retrying if those happens. So pretty great.
There was a question about configuring Maxwell space. We are at time. Let's do this. We're going to answer. Well, all the answers are going to be in our summary. So either that we answer live, you're going to find it written in the summary. So sorry for missing that question, but let's try to keep it on time for everyone. Theo, it was great. I love chatting, and I promise next time I will synchronize my watch to the correct clock. So I think we have a topic for next week. We're gonna talk about serverless. We're gonna talk deeply why serverless is a lie. Let's say that. Till then, I want to thank everyone for joining us and to invest this hour of time listening to us chat. And I hope you all got something useful for you and to answer some of your questions. Like I said, we invite everyone to try our open source tool. And if you are interested in trying anything of our commercial tool, reach out directly to us. We would love to demo you what we are building and show you why some stuff that we build are saving to everyone's time and especially frustration. Till the next week, I want to say goodbye to everyone. Thanks again, and see you next Wednesday at same time, same place. I would say same people. It's an appointment. It's a date. Let's call it a date.
A date. Look, come on.
It's a date. Thanks, Theo, for joining us today. Thanks to myself to join today. And we see each other next Wednesday. Ciao a tutti. Ciao ragazzi.
Ciao. Bye.
Bye bye.
Okay.